Hello everyone, and thank you for attending this presentation of Myths and Realities of the Electronic Manufacturer Certificate of Conformance. My name is Gary Beckstedt, and I'm the Director of Operations and Quality at Flip Electronics in Roswell, Georgia. Flip is an authorized distributor that specializes in finding end-of-life and obsolescence solutions for our customers while avoiding the perils of the open market. Please let me start by thanking the Atlanta and Space Coast chapters of the SMTA for making an amazing pivot and finding a way to ensure that each of us has access to continuing education opportunities despite the current social upheavals. Their dedication to this organization is a testimony to their professionalism and their commitment to our industries. Thank you to each and every one of you. The Certificate of Conformance, especially the Manufacturer's Certificate of Conformance, has been considered the holy grail of part validation for quite a while now. In addition to many customer purchase order terms and conditions, a requirement for a CSC, whether the suppliers or the manufacturers, appears in numerous standards and regulations. These include AS 6174, which deals with controlling counterfeit material, AS 6081, which addresses fraudulent and counterfeit electronic parts controls in the open market supply chain, and AS 6496, which covers fraudulent and counterfeit electronic parts controls in the authorized or franchise distribution supply chain. Additionally, at least two federal acquisition regulations identify processes and controls involving CFCs, FAR 52.246-15 and FAR 46.504. Its inclusion in so many technical requirements is an indicator of the power of this document. More than just a packing list, a CFC can provide an additional level of confidence in the authenticity of purchased parts. Some even communicate technical information, such as date codes or countries of origin, that are not or cannot be marked on the parts themselves. CFCs can even be instrumental in establishing the chain of custody of components to fulfill military traceability requirements. But how reliable is the CFC in terms of mitigating the risks of obtaining non-conforming or even counterfeit parts? While AS 6496, AS 6081, and AS 6174 all outline their own requirements for the information included in a CFC, none of these is binding on the manufacturer themselves. In fact, I'm unaware of any regulatory, statutory, or even industry requirement that explicitly outlines the format or content of a manufacturer's CFC. Simply put, the manufacturer can structure the document however they want. And this brings us to our first myth. The manufacturer's CFC always contains blank. Insert whatever requirement is important to you. I've seen documents that contain as little as part numbers and quantities with a basic statement of conformance to those that identify even the date code of the moisture barrier bag's sealing. So what makes a certificate of conformance a valid CFC? Lacking an authoritative source, I'll share with you my opinion. First, it should include a full identification of the party to whom the CFC has been issued. This includes the company name, address, and purchase order number. This information becomes critical in the event that communication with the manufacturer is opened up and allows them to trace the specific order to the actual part information. Second, it should have the part number and quantity which is covered by the CFC. An order for 5,000 parts with a CFC that only covers 1,000 is missing paperwork at least, or fraudulent at the worst. And finally, it must have some form of a statement of conformance that identifies what criteria the parts meet. Without this formal statement, your document becomes a packing list and does not serve as a valid CFC. Consider this CFC from NXP, for example. Just a quick glance at the document overall, you see in the top left corner that it self-identifies as a packing list. So does this contain the information that we're expecting in order to qualify as a CFC? Well, let's look closely at the header. On the right-hand side, you can see the ship to address is to Flip Electronics, and it's being shipped directly from NXP Semiconductors, Netherlands. Down towards the bottom in the center, we can see the purchase order number of 403918.1, and below and to the left of that, in the description field, is the part number. Immediately below that, we see that these parts were shipped in 3 separate containers, the quantity of which is identified in the column on the right. Additionally, NXP has provided us the country of origin information, in this case Taiwan, and as a bonus has indicated the RoHS compliance of these parts. At the footer of the CFC, we see the shipment quantity total on the left-hand side of 13,000. Immediately below that, that conformance statement that I was referring to earlier, and then a signature by some quality engineer and their date. So this would qualify as a C of C. Please notice, though, that some pieces of information that are traditionally thought to be important on a C of C are missing. In this case, there's no information regarding date codes, lot codes, or even version indicators. And while this does make it far more difficult for an end user to link the parts received to the document, additional information on the C of C allows the manufacturer to determine the lots that were shipped under this certification. Now, on the other hand, consider this C of C provided by Cypress Semiconductor. Again, a quick glance at the document, and in the top center we see this actually does identify itself as a certificate of conformance. Let's make sure all the information that we need is there. In the top of the document, we see on the left-hand side that the parts were sold by Cypress Semiconductor. They were billed and shipped directly to Flip Electronics. On the left-hand side, the customer purchase order 403704.1, the Cypress part number below that, and then the table to the right that indicates all of the quantities that were shipped, also identifying their mark lot codes, their mark date codes, and even the date that they were soldered. Going down to the bottom of the document, we see a declaration of conformance, this time less of a formal conformance statement and more of a list of all of the conformances that were achieved. For instance, all product passed 100% electrical testing, traceability records and screening data on file and maintained, etc., etc. So again, this does qualify as a C of C. Now, why wouldn't the manufacturer just include those kinds of details on the C of C and make it easier for the end user? That's a great question. Unfortunately, the best explanation I've heard is the concern that providing too much information allows miscreants to generate counterfeit documents. And that brings us to our second myth. The manufacturer C of C proves the parts are authentic. Consider for a moment the technical expertise required to produce a counterfeit part. Supposing we are referring to simple blacktopping, you need the ability to produce the blacktop material, the tools to apply the blacktopping without affecting the leads, and the equipment needed to laser etch the new markings onto the part. If an unscrupulous actor has the technical knowledge to blacktop parts, surely they have the ability to draft false documentation. Also, please don't confuse a C of C with the chain of custody of a component. When purchasing parts from authorized distributors like Flip Electronics, the C of C will typically demonstrate that the parts were shipped by the manufacturer directly to the supplier you are engaging. However, if there have been intermediaries, the C of C will not reflect who held the parts, for how long, or how they were handled. Our final myth is we have the C of C, so we know the parts will work as we expect. A typical C of C includes a statement of conformance that usually reads something like, "We certify these parts meet the requirements of our design specifications." Based on this statement, it's not unreasonable to believe that the parts will perform as the datasheet describes. And using this datasheet, you designed your specific application for the part. However, somewhere in the text of nearly all datasheets is another comment from the manufacturer that states, "We assume no responsibility for the accuracy of this information and reserve the right to make changes with or without updating this datasheet." Now, if you reread the statement of conformance, you'll notice that it doesn't confirm the parts meet the datasheet requirements, rather that they meet the manufacturer's testing requirements. And those testing requirements may or may not match the published datasheet. So what value does having the manufacturer's C of C bring to our efforts to avoid non-conforming and counterfeit components? By itself, very little. But the same is true of every element of product validation. Labels are easily forged, X-ray analysis won't necessarily detect previous use, and visual inspection won't detect incorrect die. Taken into consideration with other observations, a C of C can become a very powerful tool in identifying red flags that lead to accurate determinations regarding the authenticity of your purchased parts. For instance, during your receiving process, it should be a matter of practice to ensure that the information that is contained on the C of C is consistent with the labels and any part markings. This includes the country of origin, date codes, lot codes, and actual quantities. Any deviations in these data points should be resolved before your final receipt. Another example would be a quality check of the CFC itself. Is the font type and size consistent across the entire document? If not, those areas that do not match could be an indication that the document has been edited from its original content. Are there typos or very odd uses of grammar? These could be signs that the entire document is a forgery. An inauthentic manufacturer's CFC could be a very good sign that your supplier is not being forthright regarding the history of these parts. Ultimately, our product validation processes need to include a variety of checkpoints. These include sourcing from reputable suppliers, preferably those authorized by your manufacturer, a robust supplier documentation review process, and where applicable, a strong component inspection process. In the context of such a validation process, the manufacturer's CFC rises to the level of importance that the general industry ascribes to it. I want to thank you for your ongoing support of your local SMTA chapter and for attending this presentation. If you have additional questions, I'll be glad to answer them. I hope you have a nice day.